Hello everyone. I hope you can hear me. Welcome back to Game Formation. Today's video I've created a very long PPT. I'll be going through three modules over mathematics. I know some topics could be repeated, but it could help you understand a little bit better. Okay. So we'll get started in a few minutes. Thank you. Okay. Okay, so shall we get started? Okay, testing one, two, three. Okay, just give me a second. Okay, everything over. Okay, keep it. Okay, um, I'll just decrease my thing a little bit and just move her this so that I can move this a little up. I know I shouldn't be doing this now, but sorry. Sorry. I'm um sponsoring this video by Wave Video, who helps me with all the new stuff. Uh, Anyways, let's put some music in the background and let's get started. Yes. Let's upload. Oh, so let's see. Okay, now shall we get started? Okay. So this is like a mathematics. So this is like a mathematics PPT which I have made for all of you. Just so you can use my decreases a little bit. Hold it. Sorry about that. Just got a quick call from someone. Okay, anyways, moving back. Now, I'm putting up a QR code. I'll be putting up a QR code up right to join my live stream. So you guys can ask questions to me live. Okay, this will stay up this for some time. Okay, I'll do it. Hold it. In this time. Okay, that's great. Okay, anyways, I'm showing both my best live stream. Maybe you need to download anything, your laptop will not crash or anything. Okay. Now let's just get back to the video, shall we? Okay. Let's hope I'm audible. Now, we're going over to this is a mathematics course with all topics that we discussed. This PPT will not be shared anywhere except no. No, I'm just kidding. There's no exception in the server, but this is too long for me to do. As you see, there's 55 slides and keep on increasing and increasing. That's it. Okay, let's get started. I'm the owner of the nation game server technically, and the nation. Owner of nation game server has this concept. Now, so here's the nation game server link, which is active 24/7. I'm not put in the description. I'll put in the comment section of the video. And here's my YouTube channel link. So let's get started. Now we're going to module 1. Foundations of basic mathematics. First, we're going to covering about number-specific properties, the natural numbers, the integers, the rational numbers, and the real numbers. We're going to the arithmetic operations of priority, masking the order of operations. That's the bottom of the Then we're going to fractions, decimals. We'll be going to fractions, decimals, and percentages, conversions, common denominators, and real world applications. Real world properties. Now, first we're going to be covering numbers and properties, part of module 1, foundation of basic mathematics. So there are 6 different types of natural numbers. Pause the video here and think about these 6 different types of natural numbers. I'm going to give you 1 minute. 2 seconds. Okay, I should answer. So first one we have is natural numbers. We have our whole numbers and then we have integers. Next we'll be going towards rational numbers, our irrational numbers, and our real numbers. Now, there's something here which is missing. We have a natural, we have the integers, we have the rational, and the real numbers. 2 missing. Pause the video for a few seconds, some time to figure out what it is. I'm going to say the answer now. It's irrational numbers and whole numbers. So we'll be covering that also today. Okay. I'm also sponsoring this video by Slide Pilot. Slide Pilot is like an app where you can control your PPT from a casted TV or any device which is near you. You can also use unified remote if you have a good laptop which will not crash like mine. So you can do basic stuff like keyboard, your functions, you're shutting it down, restarting, and much more. Okay, so you need to download from the computer and your phone to link it together. I did it, but then instead of crash, so then I just deleted it. Yeah, right. Okay. Starting off, we have is natural numbers. So, okay. Firstly, we have is the standard counting numbers. It starts from 1 to infinity. We have a mathematical set right here. Definition is the absolute baseline of discrete mathematics, often referred to as a positive counting number. Now we have the mathematical set. It goes from 1, 2, 3, 4, 5, and so on. But now, why is it not 0? Coming back to it now. This is a critical restriction. Okay, so this set is bounded below by 1, but it strictly excludes 0, all negative magnitudes, fractions, and decimals. It is closed under addition and multiplication. Adding or multiplying two natural numbers always yields another natural number, but not close under subtraction or division. You generally need to know, not need to know much about it. Just need to know it's not zero. Okay, definition nobody will ask, but you just need to know it. Okay. Now let's go on to whole numbers and then we go to integers. Now whole numbers. What's a whole number? I'm going to explain my way. If you see this picture up here, you can see whole numbers here. Whole numbers contain natural numbers and whole numbers, which meaning the number zero itself. So here, mathematics, okay, 0, 1, 2, 3, 4, and so on. Whole numbers meaning not decimals or fractions, percentages. It's a whole number like 1, 2, 3, 4, 5, 6, 99, 55, 50, like that. So there is one critical restriction: the inclusion of the structural placeholder zero. It allows for the expression of absolute null value of empty sets. You don't need to know what it means, but yeah, you just need to know that. Now, going on to integers, we have definition. Now, anyone tell me what the definition of an integer is? Don't worry, my laptop cannot crash. I just put a black screen. So we have these many slides, and then we finish this. This is just a temporary one. Keep on adding it from here. Okay. Uh, Going back, integer is like it's a combination of positive numbers, negative numbers, and a whole numbers, right? So it's a completely unified linear network that introduces the concept of direction, additive inverses, and negative values. Sorry. So in the next module, before we go further in the next module, I'll be talking about functions, like the flow diagrams, the f of x, like suppose f of x 2x plus 1. Okay, I'm not going to explain it, but I'll be going more into it in the next video. I'll explain. Okay, anyway, mathematical set for integers includes whole numbers, natural numbers, and integers, meaning all negative numbers. So it comes from minus negative infinity all the way to infinity, including 0. Now, there's a critical restriction here too. So, critical restriction. Now, the integers contain 0 fractional or decimal parts, right? So, this set introduces closure under this. I don't know exactly how to read it out, but yeah, I'm gonna come back to you. This is part of sets and intervals, which is not part of this video, but I'm gonna add to this presentation later so we can understand the statement. Okay. Now, this is vital for balancing structural accounts or measuring vector movement backward and forward from a zero point. Before we go into the rest, let me just make sure that I'm actually presenting so that nothing happens. Okay, okay, okay. Ah, okay. So I'm currently using light palette controller so it makes my life. We're going to three streams this slide: rational, real, and now. Now, note this down because this is going to be very important. So, any number that can be expressed as a strict ratio of two integers, meaning a by b, where a and b is a natural number and b is not equal to 0. If b was equal to 0, if you even though you had a variable, it's gonna be counted as mathematically undefined. Okay, so this is a critical restriction. Okay, so now the decimals in this category behave in exactly two ways: the terminating decimals and repeating decimals. So what are terminating decimals? So they come to a complete clean end. For example, we take 3 by 8. We have 0.375. Okay, we have 0.375. We have 0. Uh, uh, we have 0.375. Why this keeps coming up on the side? um folded something. Yeah, I'm currently casting it there, so it comes here because the app's connected to my TV, which controls the laptop. So that's what I'm using. I'm sorry for the delay. Uh, Going back. So determining decimals, they come to a. Oh my god. Is with this thing coming up, of course. I think there's something wrong here. So sorry. So sorry. I don't know what's happening today. Okay. So going back, they come to a complete and clean end. For example, you have 3 by 8, which is 0.375. So it doesn't go like 0.3756789 and goes on. And it's completely after 5 has been seen. Repeating decimals. Here, they like a repeat a specific pattern infinitely. Suppose you take t by 3 here, become 0.6666666 and so on, right? Now, we need to find a way to get this bar. Like, say only one number, and but it represents infinite. So that's why you can use the bar. I can't really write here because of the thing, but next time I'll make sure. So, okay. So I've zoomed in so you guys can just see it better. Okay. Now, so specific pattern. Uh, okay. Specific pattern. Okay. Now, well, next we have another example. 1/7. You get 0.142857 or 1428571422857 and so on. So here, so you can put a bar, 142857. Put a bar over it, and then it comes as it. Yeah. Next, you have real numbers. The definition of a real number is a supreme set that unifies all possible conscious measurement. The key attribute here is the accounts for every single physical point along a continuous geometric line. So here is a mathematical set. Again, when you go to such an intervals, you talk about this. Now, irrational numbers are like just the opposite of rational numbers. Okay, I'll say why now. So here, rational numbers go from this mathematical set, but irrational numbers defies this mathematical set and does not follow it. Get it? I hope you understand it. I'll repeat. So as you know, the rational numbers require a specific formula already. The a by b, where a and b are natural numbers, no, I think it's real numbers, and where and b is not equal to 0 as but here it completely defies that and does not follow it. For example, we have root 2, so you have 1.414213 so on. Say for 3 pi or the Euler's number e, 2.71828 and so on, right? I hope you have understanding. If you don't, you can like come to my Discord server and message me. I can always teach you guys. Okay, completely loyal to guys. Okay, next we're moving on to properties of real numbers. Okay, just ignore these. Okay, I and ignore the missing picture. I ignore this too. I've missed a few pictures, so I'll come back to that again. I'll come back to this topic later. Okay, so here rearranging the order of numbers does not alter the final result. For example, we have addition. A plus B is the same as B plus A, and A times B is the same as B times A. Here, okay, so these two will come back later with another example. Okay, so now let's go to multiply. Is there like uh, or consider this a arithmetic priority. Okay. Um, Hello. Okay, just 1 second. I'll. This is there. I just put this up here. And then cast it again. I don't know why it's acting this way. Actually, it never does like this, but this is new. Okay. So we saw all the things here. Saw this. Now we go on to next. Okay. So first of all, we have the order of operations. We have bed mass and we have bod mass. The first thing you need to know is the full form first. Okay. First, P or B. P stands for parenthesis. B stands for brackets. E stands for exponents. O stands for orders. Meaning orders meaning powers, roots, indices. Okay. MD meaning multiplication and division. It's any DM, but here it says MD. Here it says DM. Just it's processed from left to right. So then you have AS, which is addition subtraction, processed from left to right again. And then we have this huge thing which will come back to me. Now, now let's go. Okay, now I want you to solve this. Okay, the answer here is incorrect. So I'll leave this as homework. Something like a homework. I'll come back with a really correct answer for this. Okay. Now let's move on to fraction, decimals, and percentages. So after we finish module one, we'll take a small 5 minute break and take a small break. If you won't take a break, I'll just end this live afterwards. Okay. Now fractions, decimals, and percentages. So you have a fraction. It's represented by numerator over denominator. Your decimals have a base 10 position notation split by decimal points. Suppose you have 0.1, 0.2, 20.2, 50.2, 100.2, you have the 0.02, and so on. Then you have percentages, which is scaled on a portion of 100, and this 100 is symbolized as a percentage. Okay. Now let's go. Fraction to decimal. You're going to divide the numerator by the denominator. Decimal to percentage. Simply multiply the decimal value by 100. Percentage and fraction. Place a percentage number over 100 and simplify. Now here's an example. So you have 3 by 4, 3 by 4, you get 0.75. If you multiply this by 100, you get 75%. And if you take this 75% and then do this, 75 over 100, you get 3. Okay? Now, moving on to operation fractions, you know this, all this addition, subtraction, multiplication, and division. I'll just skip this one. Oh. Now go move on to, now we go on. This is module 2, exponents and powers. Now we'll just go through this, go to the introduction, and we stop here. So now, when you hear the words exponents and power, think what comes to your mind and see the meaning. Like what meaning comes behind its exponents and powers. Well, now we'll be discussing this here. Introduction to powers will be understanding base values, positive exponents, repeated multiplication, the laws of exponents, product, quotient, power of power, and zero exponent rules. Then we go to negative and fractional exponents. Okay, meaning we go to reciprocals, square roots, cube roots, and radical conversions. Scientific notation expressing massive and microscopic values using these powers. Okay, let's get started. And like just do this basic part, and then we'll just move on to the module 3. Okay, loss of exponents. So whenever we have a variable which contain exponents and have equal bases, we can do certain mathematical operations to them. These operations are called the loss of exponents. Now it's a general formula for it. B by B power x, where B is a base and x is an exponent. Okay. So these are some rules, some other properties. Then you have your basic examples. Then you have a test for laws of exponents. Okay, don't see this, don't see this, don't see this. Skip this stuff. I'm showing it. Okay, just a second. I'll just skip. Yeah, as you can see, we have scientific notation and then we have module. Let's go to module 3. So we'll be discussing what's an equation, techniques for an equation, when a power x equals a power y, why learn equations, isolating variables. Okay, don't listen to this. I didn't change this yet. Okay, it's still under construction in PPT. Okay, don't. Definition, types of equations. Okay, now let's get started. What's an equation? The equation is a statement that two expressions are equal using an equal sign. Equal to. For example, we have 3 plus x equals 7. Now again I'm saying this, and I've said this more times already, but equal sign makes an equation. Okay. Now going on to why learn equations. Equation help us solve problems to find unknown values, right? So they're like used in barely activities like science, engineering, economics, daily activities. Learning equations develop logical thinking skills. Now we're moving on to definition and types of equations. There are three types of equations. Now I want you to say what these three types of equations are. Because it's a big fat number 3 here. Well, one of it is linear. Now the answer. One of it's linear equation, then you have quadratic equation. Third one is not really type, it's just a part of linear equation, but whatever. So it's a linear equation with variables. I will start with this. So these, okay, I won't go into this today. I'll be going to this and then next, um, next video. Yeah. So these are for quadratic, the product problems, some variables on both sides. Okay, so these are summary key takeaways. There's some practice problems with the answers here. Okay, and then yeah. Okay, so thanks for watching. I hope you enjoyed. And I completely forgot something which I was not supposed to, but yeah, it's whatever. But I hope you enjoyed. Okay, like and subscribe, and like subscribe, join a Discord server. Okay, join the Discord server. It's gonna be really helpful for you. So like having a- having a Discord server is not easy actually. It's kind of hard at the same time. Yeah, but whatever. There's going to be and in the next video, I'm not going to be going with my PPT. I have a bunch of presentations which I was supposed to do today, which I haven't done because I created my own here, as you saw 2 seconds ago. Anyways, it's weird. Okay, whatever. So I hope you have enjoyed the video. Like and subscribe, people. Like and subscribe. Join my Discord server. Turn on your notifications for new. See you in the next one. Peace.
Do you feel the